Good day, everyone. In today's discussion, we are going to tackle about tension force problems, wherein we are going to include problems that includes two ropes or cables which is inclined in a certain angle. And we are also include static equilibrium, and we are also going to apply what we learned on the past, like your past lab. But to formally start on our discussion, let's watch this video. In today's discussion, we are going to tackle about tension force problem, which is we are going to solve different problems involving two ropes on hanging mass with angles, and we are going to apply the concept of static equilibrium and the Newton's law of motion, especially the second law of motion. And we formally start our discussion by reading this example. A rope is used to lift a 100 kilogram box with an upward acceleration of 5.3 meter per second squared. And the first problem is, what is the tension in the rope? So we're going to answer first letter A. So in answering tension force problem, it is a really big help to know the free body diagram. So here here is the box, which is 100 kilogram, and we have the tension, which is what are we looking for. Then aside from that, we have also a force here, which is the weight. Okay, weight is the combination of mass times gravity, and according to the given, there is an upward acceleration of 5.3 meter per second squared. Therefore, our F net is in upward motion or in a positive direction. Then, after knowing the free body diagram, let's proceed to this equation. Since our convention is along y, we have the summation, okay? Since it involves motion along y, so we have summation of force along y, which is equal to T, or the tension, which is in upward motion, therefore it is positive, and the weight, which is on downward motion. That is why it become negative. Therefore, our equation is T minus W. Then, as we all know, and we recall the Newton's second law of motion, we know that the summation of force is equal to mass times acceleration. So we can write this as this, okay? And since it is along y, we can write this as mass times acceleration along y. Then is equal to T minus W. Then, what we do next is to isolate the equation. So, to get the value of tension, we just simply isolate the equation. And we all know that T is now become T is equal to MA along Y plus weight, as like what I said, it is also write as mass times gravity. Therefore, the equation for tension in letter A is mass times the quantity of AY plus G. So that is the equation in order to get the tension in letter A. So we can write now the equation. T is equal to mass times the quantity of A, acceleration along Y, plus gravity. Then we can substitute the value of mass as 100 kilogram times the quantity of acceleration along Y is which is 5.3 meter per second squared plus the value of gravity we can write as 9.8 meter per second squared. Now let's proceed to further solution. 100 times 5.3 plus 9.8 is equal to 15.1. Then we get 100 times 15.1 is 1510 Newton. And that is the value of tension for letter A. Okay, that is our answer for letter A. Now, let's proceed to letter B, which is what would be the tension in the rope if the box descended slowly with a downward acceleration of 0.75 meter per second squared. Again, let's proceed to our pre-body diagram because pre-body diagram is really helpful in tension force problems. So, by this time, we have tension in upward motion and weight for downward motion. And by this time, it was said in the problem that it descended slowly with downward acceleration. So our F net here is in a downward acceleration. And therefore, we have get the equation, meaning the convention for the equation is just simply negative. So, negative summation of F along Y is equal to, which is present, the positive motion, which is tension, minus weight, which is in the downward motion. So, okay, let's just write it again. Okay, like this. And like what we know, summation of force is equal to ma. But since mass is a scalar, we don't need to write it as negative. So we have this equation now, which is mass times the negative acceleration along y plus w is equal to tension, which is we all know that weight is equal to mass times gravity. So we have this equation. We can write it as mass times the quantity of, which is involved, the negative acceleration y and the gravity. Okay, after knowing this equation, okay, to make it in a static view, we can write this as like this. Okay, now after knowing the equation, we can go to substitution. So we have tension is equal to mass times the quantity of gravity. Since it is in downward motion, we have negative ay or minus ay. So mass, okay, then okay, we can now substitute the value, which is mass is 100 kilogram, then times gravity, which is 9.8 meter per second square, minus by this time 0.75 meter per second square. Then for further solution, we have 100 times 9.8 minus 0.75 is 9.05. Then therefore, we have 100 times 9.05 is equal to 905 Newton. Then that is our answer for letter B, 905 Newton. And by this time, we have another problem. What is the tension in the two ropes in the picture below? As we can see, we have two ropes, the T1 and T2, and we also have angles. So in T2, we have the Tx sub 2 and Ty sub 2. And on another side, we also have the Tx sub 1 and the Ty sub 1. what you notice here is we form a a triangle, and we have also the given weight here, and the mass of the box is 50 kilogram. So we already analyzed the picture. Now the technique here is just simply separate the values, which is along x and along y. By this time, we just treat first the values along x, and we have the summation of f of x is equal to here the t x sub 2 minus t x sub 1. And since the object is not moving, so the summation of x is 0, is equal to t x sub 2 minus, okay, t x sub 1. So the summation of forces becomes 0 because the object is not moving. Therefore, t x sub 1 is equal to t x sub 2. And since we include angles here, we all know, based on previous discussion or on other discussions that we learned or in the past, that t sub x is also equal to t cosine theta. Therefore, we have this t1 cosine theta 1 is equal to t sub 2 cosine theta 2. And let's just substitute the given angles. Okay, we get t1, then cosine, so what would be the angle is 30, then is equal to t2, then cosine 60. Then we can calculate the value of cosine 30 and cosine 60. And based on our calculation, the value of cosine 30 is 0.87. Then the value of cosine 60 is, the value is 0.5. Then we can use, or we can divide 0.87 on both sides to simply get the value of t1 or the equation for t1. Then we have this value. So the equation for t sub 1 is equal to 0.5 divided by 0.87 is 0.57 t sub 2. So that is the equation for t sub 1. After getting the equation for t sub 1, let's treat now the value along y. So we have summation of f sub y, which is equal to t y sub 1, then plus, since ty sub 2 is also on the upward motion, then minus w, which is weight, which is it is on a downward motion. Now, since the object is not moving or is at rest, therefore the summation of force along y is 0. Then we have t y sub 1 plus t y sub 2. Then we can write weight as mass times gravity. Now we can isolate the equation. We can have mass times gravity is equal to t y sub 1 plus t y sub 2. And as we all know, the value of m, or the mass here, or the box, is 50 kilograms. So the mass of the box is 50 kilograms times the gravity, which is 9.8 meter per second square. Then we all know that the value of t sub y is t sine theta. Therefore, we have t sub 1 sine theta, then put 1 here, sub 1, plus t sub 2, then sine theta sub 2, for us to recognize the difference of angle. Now, we have 50 times 9.8 is equal to 490 Newton, since it is weight or a force, is equal to t sub 1 sine, then the angle here is 30. Okay, we have 30, so we have 30 plus t sub 2, then sine 60. Then we can compute for the values of sine 30 and sine 60. So by computing it on the calculator, we have 490 Newton is equal to, so sine 30 is equal to 0.5. Then we can write t sub 1 plus the value of sine 60 is based on our calculation, we have 0.87 t sub 2. And by this time, we can now substitute the equation for t sub 1 in order for us to get or to have t sub 2 only in the equation. So we can just substitute the equation for t sub 1. So we have now this equation. 490 Newton is equal to 0.5. Then the value of t sub 1 is 0.57. Then we have t sub 2. Then plus 0.87. Then t sub 2. Then let's proceed for the solution or for further solution. We have 490 Newton is equal to 0.5 times 0.57 is equal to 0.29. T sub 2 plus 0.87 T sub 2. And by this time, we only have one variable, which is t sub 2. And we can easily compute for the given values. So we have 490 Newton, 0.29 plus 0.87 t sub 2, we get 1.155 t sub 2. So we can divide 1.155 on both sides to get the value of t sub 2. So divide it. 490 Newton divided by 1.155 is equal, okay. So the value of t sub 2 based on our calculation is equal to 424.24 Newton. That is the value of t sub 2. And way back on our previous equation, which is the t sub 1 equals 0.57, then t sub 2. Now that we already know the value of 0 or 2 t sub 2, we can simply substitute it. So we have 424.24 Newton, then multiply to 0.57, we get 2 41.82 Newton. So that is the value for T sub 1. After knowing the value of T sub 1 and T sub 2, we're getting the values of other variables involved, which is the value of T sub x, Tx sub 2, Tx sub 1, Ty sub 2, and Ty sub 1. But first, let's write the answers for T sub 1 and the answer for T sub 2. Okay, 424.24 Newton. Okay, first, let us proceed to getting the values on T sub 2. So let us first get the value for T sub 2 or Tx sub 2 first. Okay, we have this time we have Tx sub 2, or we have Tx sub 2 is equal to T sub 2 cosine theta sub 2. So the value of T sub 2 is 424.24 Newton. Then cosine 60. We have cosine 60. Then let us compute it. And the value of Tx sub 2 is 212.12 Newton. So that is the value of Tx sub 2. Then let's get the value of Ty sub 2. So it is positive because it is on the right side, and the Ty sub 2 is also positive because it is upward. So we have T sub 2 now sine theta sub 2. So again, let's substitute the values. We have 424.24, then sine the angle for T sub 2 is 60. So we have get, okay, based on our calculation, we get 367.40 Newton. So that is the value for T sub 2. That are the values for T sub 2 rather. Now let's proceed for the values along T sub 1. Now let's try Tx sub 1 first. So we have T sub 1 cosine theta sub 1. So the value for T sub 1 is 241 point, okay, 0.82. So 241.82 Newton. Then we have cosine 30. Then our answer is 209.42 Newton. Okay. Now, the value for Ty sub 1 is equal to T sub 1 sine theta sub 1. Okay. We have, okay, it should be sub 1. My mistake, sorry. Should be sub 1, not sub 2. So we have 241.82 Newton. Then sine 30. It should be sub 1, not sub 2. Okay, this is my mistake. Okay. Now we get the answer 120.91 Newton. Okay. Okay. as we all know that tx sub 1 is on the left side, therefore it should be negative. So it should be negative 209.42 Newton. Okay. Now, let's try this another example. Calculate the tension in the given two ropes below. So first, analyze the picture. We have two tension given, the T sub 1 and the T sub 2. Then T sub 1 includes angle, which is 30 degree. And the box had the mass 50 kilogram. So first, we have motion along Y, which is weight, which is in downward motion. Then we also include the Tx sub 1, which is on the left side. Therefore, it should be negative. Then we also have the Ty sub 1 in upward motion. So, in T sub 1, we form a triangle. And now, let's calculate the value. And first, we're going to treat first the values along Y. So we have the summation of F along Y. So we have values which includes the Ty sub 1 and another values include in Y ordinate is the negative W. And since the object is at rest, the summation of force is 0. Then we have Ty sub 1 minus W. Therefore, when we isolate the equation, we have weight is equal to Ty sub 1. Then we all know that weight is also equal to, right? Weight is also equal to mass times the gravity. And also, we all know that T sub Y is also equal to T sine theta. So we have now T sub 1 sine theta. Since we only have one angle, we don't need to write sub 1. So we have 50 kilogram and the gravity is 9.8 meter per second square. Then the value of T sub 1, which we don't know, so that is what we're looking for. So then we have the angle sine 30. So we have sine 30. Okay, we have sine 30. So 50 times 9.8 is equal to 490. Since it is weight, so we have Newton. So sine 30 is equal to 0.5. So we have T sub 1. So we can divide 0.5 on both sides. Then we get the value for T sub 1, which is equal to T sub 1 is equal to 980 Newton. And now, we are going to solve the values which is along x direction, or the summation of f of x, wherein we involve the tension in rope 2 or T sub 2 and minus Tx sub 1, which is what you see on the free body diagram. Since the object is at rest, so the summation is 0. Then we have T sub 2 minus T sub 1 x. Therefore, if we isolate the equation, we have get that T sub 2 is equal to Tx sub 1. And T sub 2 is equal to, we all know that Tx sub 1 is also equal to T1 cosine theta. So, and we all know the given angle. So, and we all know also the value of T sub 1, which is 900, okay? It should be 980 Newton. Then 980 Newton. Then cosine 30. So let's further compute the value of T sub 2, which is, based on our calculator, it is 848.70 Newton. After knowing the value of T sub 1 and T sub 2, which is we have 980 Newton and we have 848, okay, 848.70 Newton. Now let's compute for other values, which is the Tx sub 1 and the Ty sub 1. Okay. Let us compute first the value along x, which is we have Tx sub 1 equals T1 cosine 30, right? Then what we get here is 980 Newton cosine 30, okay? Then compute it. What we get is like the value of T sub 2. Therefore, if we solve the motion or summation of f of x, we get 0 because Tx sub 1 and T sub 2 are both in magnitude but opposite in direction, right? Now, let's compute for the value of Ty sub 1, which is T1 sine theta, or sine 30 rather. Then, substitute the value, 980 Newton sine 30, okay, which is equal to 490 Newton. So that is the value for Tx sub 1 and Ty sub 1. Then, let's compute for the value of weight because it is also on our free-body diagram. So the value of weight, which is mass times gravity, what we get, the mass is 50 kg and the gravity is 9.8 meter per second squared, we get negative 490 Newton.